All right, so we're going to continue. This is part B because we did a little bit on Friday. So we're going to continue. We got quite a bit still to do. If I could find my notes. Where in the world did I put my notes? I had them right here. Here they are. All right. So you should be taking good notes on this stuff. We did standard form. Let's review very briefly. You should just be able to look at your notes because you should have taken them on Friday. Do you remember what the standard form? Right. It's the standard form of an equation of a line. You can write that down. You can write this down. I'm just going to write standard form. It's the standard form of an equation of a line. All right. And here it is. It's AX plus BY equals C. Now, what does the A, B, and C really stand for? Well, right now, really nothing, okay? You can't just look at the A and say, oh, that's the slope, or look at the B and say, oh, that's... You guys all finished? Because it's really disturbing me after I had a big, long talk about listening, paying attention, and then you're talking while I'm talking. All right. So you can't really look at this and say, if you find what A is, you can't just say, oh, that's the slope, or you see C and say, oh, that's the whatever. You have to change this from one form to another, and we're gonna talk about that form a little bit later. But what you can do is this: if they, I think we did this in class yesterday, but what if we had, again, this is review, but I'm going to do it since we had that weekend. All right. And if I wanted you to graph this thing, if I wanted you to graph it, now they tell you specifically how to graph it. We're going to find out later today in this class another way to graph this thing. But they say graph it using the X and Y intercepts. Everybody hear what I just said? You could write that down if you want. I'm not going to, just for the sake of time. But it says graph using the X and Y intercepts. So the X-intercept, do you remember what you do to find the X-intercept? You set something. You set Y equal to 0. And then in order to find the Y-intercept, you set X is equal to 0. All right, so let's do that, and let's see what we get. So if I set Y equal to 0, so here's the Y right there. I'm going to keep everything the same. I'm just going to make that Y into a 0. So the 2X stays the same, minus 3 times Y, which is 0, equals negative 6. And what am I going to solve for here? I'm going to solve for X. So I should be able to get an ordered pair. Okay, the ordered pair would be whatever I get for X and then comma 0. All right, so let's do this. So this is 2X minus 3 times 0. I don't even have to write that down. It's 0. It's just 2X equals negative 6. I don't even have to show the work here. What's X equal to? It's negative 3 because you divide both sides by 2. So I've got X is negative 3 and Y is 0. So I have to plot that point. Okay, I got to put a point on my graph because remember what I'm trying to do. I'm trying to graph this thing. Okay, so I need 2 points. If I know 2 points, excuse me, if I need 2 points, then I can graph this line. So my ordered pair is negative 3, 0. Okay, let's do the same thing with the Y-intercept, except this time we're going to set X equal to 0. So we're going to take this and set that equal to 0. So it's going to be 2 times 0 minus 3y equals negative 6. And now we just solve for y. 2 times 0 is 0, so that's negative 3y equals negative 6. Get y by itself, divide by negative 3, okay, divide by negative 3, and so it's negative 6 divided by negative 3, which is positive 2. All right, so now the reason we did that is so we could get an ordered pair, so we could plot another point. So what's my point here? It's 0, 2, because 0 is the X and 2 is the Y. Everybody with me? All right, now if we're going to graph this thing, I'll just do a little graph like this, okay, and put some, so it's negative 3, 0, 1, 2, 3, and it's 0, 2, 1, 2. Let's just put this in a different color when I graph it. And so that's the x-intercepts. What does that mean? The x-intercept means where it crosses the x-axis. So it crosses the x-axis at negative 3, 0 right there. The y-intercept is 0, 2. So where does it cross the y-axis? It crosses the y-axis at 0, 2 right there. And then what do we do once we get those 2 points? Do we just leave the 2 points? Yeah, you make a line, okay? And so you just connect them here And then just extend this out. Now watch. We're going to put arrows on here because it is a line. Don't just connect from one dot to the other and stop it. It's not a line segment. It's a line. It keeps going through, all right? So draw it all the way through that looks like this. That looks a lot better. So what did we just do? We graphed a line, okay? And that's the equation of a line. But it's in a different form than we're going to use a lot. We don't use this form very often. Sometimes you do. But there's another form we're going to talk about in just a few minutes that we're going to use that's a little bit more useful, a little more practical. But this is still practical. We can still find the x and y intercepts, put the 2 points, make the line. Pretty easy. Okay, but there's another way to do this, and it might be just a little bit better. I'll tell you what, let's do this. Let's kind of examine this equation right here. It doesn't say anything about slopes in here at all, does it? But let's actually find the slope. I've got 2 points, right? Can I find the slope if I know 2 points? I'll tell you what, let's make this a different color. A little easier to read. So can I find the slope? Yeah, it's rise over run, or you subtract the y's and you put them on top. I saw 1 or 2 quizzes where you put the x's on top. Okay, remember, it's rise. Rise is the y direction, so the y goes on top. By the way, I don't think I said this because I was about to say it, and I don't think they've heard this before, but sometimes we call it the change in. Did I talk about that at all? It's the change in y over the change in x. Why did I put a little triangle there? What's up with that? Does anybody remember? I don't know if I said this or not. It is. Very good. That's what I was looking for. Now watch. This is a Greek letter of the alphabet. Okay? And the Greek letter is a delta. It kind of looks, it doesn't look exactly like a triangle. I think one side might be like a little bit thicker or something. I'm not sure. I'm not a Greek scholar or anything. I don't know but I do know that's a Greek letter of the alphabet, and we call delta. So we call it, there's still a lot of talking. Just wait till I'm finished, okay? Wait till I take a break, and then you can ask the question. But I'm right in the middle of it right now, okay? So this is delta y, which means the change in y, all right? Which means if you're going up and down, the change in. So from one point to the other, how do I find the change, or how do I find the distance from one point to the other? If I'm at 5 up here and I want to get to 2, how far is that? It's 3, isn't it? What did I do? Say it. I subtract. So the change in y is y2 minus y1. You learned that already, right? But I just want to show you this because a lot of times I'll refer to that. I'll refer to the slope as the change in y over the change in x, okay? And that's pretty easy. What does the change in something mean? It means you just subtract from one from the other, okay? That's all it means. No big deal. But you'll see that in other books and things like that, and probably even in here they might even mention that. But I just thought of that, and I don't think we talked about it before. So what's the change in x? It's x2 minus x1, all right? This is all review, except for the delta stuff. But this should be review, this slope stuff. So I subtract the y's from each other. Now, it doesn't matter. You don't have to go the second one minus the first one. You could go the first minus the second, but you got to go in the same order on the x's, okay? So whatever order you go on the y's, you got to go in the same order with the x's, all right? So let's just go in this order, y2 minus y1. So this is my y2, this is my y1, so what would I do? 2 minus 0. See what I did? I took the y's. I remember grading somebody's quiz, and they subtracted the x and the y's from each other. They went minus, -3 minus 0. You don't do that, okay? You subtract the y's from each other, put it on top. You subtract the x's from each other and put it on the bottom. Everybody with me? So I go 2 minus 0. What do I have to do with the x's? I have to go what? 0 minus, is it minus 3? It's minus -3, okay? And what would this be? This would be 2 over positive 3. This is positive because add the opposite, right? 2 minuses next to each other makes it positive, so it's 2 over 3. So the slope of this is 2/3. Ben, you had a question earlier.
I couldn't see this part about delta.
Okay. Oh, it was off screen. Sorry. Guess I should have answered your question. There it is. You see it right there? So it looks like a little triangle. All right, so that's what delta means. Sorry about that. All right, so why did I do that? Why did I find the slope of this thing? Okay, because the slope on a line is really, really important. There's another thing that we've already found, and that's called the y-intercept. Now, we use the lowercase letter b, to represent the y-intercept. So if you want to put a little note right there, so the letter b is the y-intercept. Okay, that's right. Okay, so the b is the y-intercept. So just looking at this graph, what is the y-intercept of this graph? It's 2, okay? It crosses the y-axis at 2. So I would say b is equal to 2. All right, now this is really important because this is what we're going to get to here in a minute. We have another form of the equation of a line that I think you've already learned in Algebra 1. And we actually talked about it in here a few days ago. All right, but it wasn't like official. I just kind of like mentioned it just to see how much you guys really knew. All right, so what we have is a slope, and we have a y-intercept. Those are two really important points, or the slope's not really a point, but there's two different things that it's important about an equation of a line. Let's write that over again. 2x minus 3y equals negative 6. 2x minus 3y equals negative 6. What I want you to do, I want you to solve for y. Okay? You with me on this? Well, not putting zeros in for anything. Just this thing right here. Just this. Okay? If I just said solve this thing for y, you're like, well, wait a minute, I can't just solve for y because I get an x in there. I don't usually have two variables. But you can solve for y. You could get y by itself. What's the first thing I'm going to get rid of? No, I'm not going to get rid of the 3. Get rid of the 2x. Always get rid of what's being added or subtracted to the y first. Okay? The 2x is being, I guess this is being subtracted from the 2x or whatever, but get rid of the 2x. Now, it's a 2x. How do I get rid of that 2x? I subtract a 2x. Then I subtract a 2x over here. Now, that's kind of weird because can I subtract a 2x from just a number? No, they're not like terms. But I can write it down, though. Okay? So right here, this adds up to 0. Bring this down. It's negative 3y equals. Now, watch what I do here. Instead of negative 6 minus 2x, I always put the x first. Okay? It's just kind of like a hierarchy of order. All right? I always put the x first. So how would I write this thing if I put the x first? Negative 2x minus 6. You with me so far? All I've done, I haven't really done much. I just subtracted a 2x from both sides, and I just kind of switched the order, put the x first. That's all I've done so far. Okay? It's just algebra stuff. Now, one more step, and I got y by itself, because that's what I wanted to do, isn't it? I wanted to solve for y. And I'll show you why in a second, okay? This is where, WHY, okay? This is where it's kind of cool, because you're probably wondering, why in the world did I do this slope and this y-intercept thing? Well, you're going to see it come right before your eyes. So what's going to happen here? I want to get y by itself, so how do I get rid of that, or how do I get the y by itself? Divide by negative 3. Now, watch very carefully. I have to divide everything over here by negative 3. So I have to divide this by negative 3, and I have to divide this by negative 3. See that? Make sure that you divide everything over here by negative 3, not just one of them. What happens here to the negative 3's? They cancels out. Y equals, look, negative over negative is what? Positive. And here's how we can write this. We can write this 2/3 x. Isn't that the same thing as 2x over 3? Sure, because 2 times x over 3 over 1. And then negative 6 over negative 3 is plus 2, not 3, it's 2. So we just solve for y. Now, look at what we had up here. Do you see anything? Do you see any relationship between these two? Absolutely. So if you were to take something written in standard form like this first one right here and turn it into and solve for y, get y by itself, you've turned it into a different form, and right before your eyes, you can look at it and you could see how to graph this thing. So you could find the what? Slope. You can just look at it and say, that's the slope right there. The thing that's next to the x is the slope. And then this thing on the end is the what? It's the y-intercept. Do you see that? And that'll work every single time. If you take something that's written in standard form, solve for y, then you can just look at it and say, oh, the thing next to the x, that's the slope. The thing being added at the end or subtracted at the end, okay, because it could be a minus as well, all right, that's the y-intercept. And that's super important right there. In fact, it's so important, we give it a name, and we call it the slope-intercept form of the equation of a line. Okay, so we had the standard form, and we have the slope-intercept form. Sometimes the slope-intercept form is really, really handy, because if they give you this equation, just like it is right now, you could graph it really simple. What I would do is graph the y-intercept first. Okay, so you just put a 2 on the y-axis, and then you do the slope. So how do you do the slope? Rise 2, run 3. Okay, and that's how you would graph something like that. It's really simple. It's called the slope-intercept form, and this is how we write it. Y equals, and again, this is familiar to you. You've done this before. mx plus b. All right, so that is the slope-intercept form. This is probably the one that's more common than the standard form. The standard form's okay. All right, you could always do the you could always do the x and y intercept to graph it. You could, if you wanted to, if it was given to you in slope in standard form, you could just solve for y and then graph it. Right? Some people think it's better to solve for y. Some people think it's better to do the x and y intercept. Right? It all depends on what they tell you on the quiz or the test. If they don't tell you, if they just say graph this thing right here, if you wanted to do the x and y intercepts, that's fine. On the homework, though, I believe they ask you to graph it like a specific way. All right, so on this one, they might say graph it using the x and y intercepts. That means you'd have to go through this stuff right here. If all they say is just graph it and nothing else, it doesn't matter which way you use it. You could just solve for y, and some people don't like doing this. Some people are like, it's a lot easier just sticking a 0 in for x and sticking a 0 in for y. That's a lot easier. But some people like this better, okay? 2 steps, right, and you're done. Subtract the 2x, divide by -3, boom, you've got it, and now you could graph this thing, okay? Does that make sense? All right, let's do an example. So this is example 2. Example 2. It says, and we're going to graph it as well. It says, write this equation in slope-intercept form. Write this down. It's very similar to what we just did. It's the same exact type of problem. Different numbers, but same style of problem. So the first thing they do is say, write it in slope-intercept form, and then graph it. Okay, that's what we're going to do. So how in the world do I take this, which is in standard form, and change it into slope-intercept form? Solve for y. Okay, so let's do that super quick. You could do the first part in your head. This is what I would do. Okay, everybody watching, I think you guys can catch this. So I would subtract a 3x from both sides, wouldn't I? So I subtract it from here, it goes away. Where am I going to put it? Am I going to put it at the end? No, I'm going to put it at the beginning and do that. Can you do that in your head like that? Okay, all I did was just move that 3x to the other side. But I had to do it by subtracting. Now, divide by 4. So I could do this without even putting that over 4 thing. So what would this be? This would be -3/4 x minus 4/4, right? If you need to do that, go ahead and do it, but it's -1. So now it's in slope-intercept form. But they're going to ask you to graph it. I'll tell you what, let me grab a graph. I like this one because okay. And let's go back to here. There we go. And let's make it bigger. All right. There. Now you can see it. And let's make my dots red so they stand out a little bit on this white graph. All right. So now, how do we graph this thing? Once you get it into this form, it's actually pretty easy to graph once you get it this way. Anthony, what are you going to do? Not yet. Not yet. Nope. You got to have a starting spot. This is your starting spot right here, the y-intercept. Okay? You got the next part right, but we got to do this first.
That's what I said. I said go over -1.
No, you said
Yeah, you said. Yeah, you were.
-1 first.
Oh, okay. But you don't really go over -1. You just go to -1 and put a dot. On the what axis? Remember, that's the slope. That's the slope. This is the what? The y-intercept. Okay, so on the y-axis, guys, up here. So we put a dot at the -1. Okay? Now, Anthony, go ahead. What do we do from that dot? We got to start at that dot right there, the -1, that point. What do you mean the x?
Negative 3/4 x.
Yeah, forget the x. What are we concerned about right now? No, you got it. What are we concerned about? We're concerned about the slope, okay? So what we're going to do is start here, and then what is the slope? It's a something over something. What is it? The rise over the run. So if it's a negative slope, you could rise over run like this, or both. You could put an and if you wanted to. You could rise over run like that. Aren't both of these the same thing as -3/4? Yeah, okay. So I'm going to do both of them just to show you it still makes a straight line, makes a line, okay? So let's go -3/4. So we rise -3. What does that mean? We rise negative. We go down 3. 1, 2, 3. And we run +4, which means we go to the right. 1, 2, 3, 4. Put a dot right there. And then you just connect the dots and you're done, okay? Or you could start at -1 and rise +3, 1, 2, 3, and run -4. Go to the left 4, 1, 2, 3, 4, right there. And they should line up. If they don't line up, you did one of the two things wrong, okay? Everybody with me on that?
Yep.
So I'm going to connect them like that, and I'm going to extend this one. Again, don't just go from one point to the other. Extend it all the way through. And it is a line, so what do we need on this thing? Need arrows, okay? And there's your graph, okay? That's the kind of stuff that they're going to ask you to do. It's not so hard, is it? No. Let me give you another one, another example. This is example 3. Example 3. I thought I had changed it to white. Let's try it again. There we go. All right, what's it say? It says write an equation of a line through -5, 6. Now you got to watch. Don't lose me now. I know I've been talking a while, but this is really important that you see this. The part that we just did was fairly simple. Okay, this part right here, it's a little bit different. So it says find or write. I think they say write. Yeah. Yeah. It says write the equation of a line. Not just any old equation, but an equation of a line that goes through this point and has this slope right here. Now, watch very carefully. Everybody's paying attention, right? So I'm going to write y = mx plus b. Now, we know what the m stands for. The m stands for the what? The slope. The b stands for the y-intercept. What about the x's and the y's? Well, what they do, an x and a y stands for a what? A point, a coordinate of a point, right? It stands for a point. What point? Any point on the line, okay? Any point on the line. Do we know in this problem, in this example, do we know a point on our line?
Yeah.
What is it?
5, 6.
No, it's -5, 6. It's -5, 6, completely different. So look what we know. We know a point, so this -5 is going to be my x, this 6 is going to be my y, and my slope, right, the m, is -1/2. So what can I solve for? If I plug all that stuff into this, what can I solve for? The y-intercept, that's right. Okay, so when we say write the equation of a line, I need to make it look like y = mx plus b. You with me? Okay, I already wrote it here. But anyway, let's plug the stuff in. What are we going to put in for y? A point on our line, right? It's the y coordinate of the point on our line. So we're going to put 6 equals m. What's the m? It's -1/2. Times, right? These are being multiplied times each other. So times -5. I'll put a dot. Now I'm going to put it over 1 since I'm multiplying by a fraction. Is that all right?
Yeah.
Okay, plus what? B, because I don't know b. I don't know the y-intercept. All right? I know the slope, but I don't know the y-intercept. but I do know a point on the line. All right, so I'm going to put that stuff in here. Now, what we're going to do is do some math, do a little bit of algebra. It's not even algebra. It's just straight up arithmetic. We want to solve for b. So 6 equals, negative times negative is positive 5 over 2 plus what? B. How do I get b by itself? Subtract a 5 over 2. And you're looking at this like, oh my goodness, Mr. Henrik, fractions, are you kidding me? Well, watch, this one's not so bad. So I subtract a 5 over 2, and I subtract a 5 over 2 here. And that cancels. That's b. That equals. Instead of writing 6, what are we going to write?
6 over 4.
How about 12 over 2, since we got a common denominator of 2 here, okay? We could write 6 over 1, but you're eventually going to have to write 12 over 2. So what's 12 over 2 minus 5 over 2? That would be 7 over 2, and that's my y-intercept, okay? Now, how do I write the equation of a line with all that information? Let's see. Because 12 over 2 minus 5 over 2. 12 minus 5 is 7 over 2, okay? So how do I write the equation of a line? I write y equals m. What was the m on this problem? No, what was the m? It's negative 1/2. They told us the slope. And then you put an x. Now we had to find the y-intercept, and we found it to be what? 7 over 2. So plus 7 over 2. That is the equation of a line. Now I don't have enough time because the bell's going to ring any second. But if we were to graph this thing, what would you do? You would put a point at, where is 7 over 2, by the way? 3.5. It's 3.5. It's 3.5. That's the y-intercept. So you put a dot at 3.5, and then you could rise negative 1, run 2, put another dot, connect them. You got your graph. Okay? So you have your, I don't have one in front of me because I passed them all out. What's the assignment? 1 through 27. So it's section what? I know, I don't have it in front of me. It's 3.5, page, what was the page? 140? 1 through 27, and I just gave you the odds to do. Okay, so just do the odds. All right, that's it.